Hello, today I'm going to show you how to use analytic hierarchy process AHP for decision making. I'm going to use a practical example of selecting a phone model because I kind of narrowed down maybe four phone models from which I have to select one, and I'm kind of wavering between like which one is the best, because this Moto X style has like very nice camera, it is Android OS, and I get speed, and then iPhone 7 is expensive, and Moto G4 is very cheap, but I have to find out the relative cost. So basically I have to also find out the cost benefit analysis. In addition, I have to prioritize, like I have to make a decision, so I have to prioritize various criteria and kind of choose between the priorities. So analytic hierarchy process is a mathematical and psychological approach for decision making process, and it has been used in many areas, in political areas and in scientific areas, as well as in project management areas to solve problems. Also, you can apply this in your everyday life. So I took this everyday life example to demonstrate with a single example. So as you can see, like I have chosen these phone models which are listed on this screen in these rows, and I have listed all these parameters which are important. You can also call it as criteria like camera, screen, battery, software support, speed, score, cost, etc. Don't worry about what each one of that mean. I just gave this as an example, and from which you can find out the score. That is what we are after, like this score for each of these phones. For Moto X style, it is 88 score, and G4 81, Samsung S5 63, and iPhone 7 99, and so on. Anyway, so we got this score, and then these are the example costs for this phone, how much it would cost in the market, and then I found a relative cost from this cost. What I did was, like, I took the minimum cost here, like, which is 200 among all these, and then I kind of divided the cost by this minimum cost. So I got, like, for example, Moto X style is 2 times expensive than Moto G4 Plus. So that's why I got these numbers. This is 2 times expensive. These are 1.75 and 3.5 times expensive. So you got a relative cost. So I plotted this relative cost in the cost benefit graph. So relative cost here in the x-axis and benefit in the y-axis. Now, how I got this, I will explain in a minute. But so what is the application of this AHP? As you can see, after we plot this graph, you can see that 81.6, this one, this bubble here, is the best option for us because it has 80 benefit, score 80 as benefit, and cost is 1. But when you go here, it is 2 times expensive relative cost, but it's almost 80.88 weight. 88 value is 88. So it is 2 times expensive. So this is 1 time expensive, this is 2 times expensive, this is 3 times expensive, but you get a little bit more benefits. Obviously, this is the best option for us to buy. So which one is this? Moto G4 Plus. Okay, now let's dive into the details. How I did this. As I mentioned, you just list the criteria here in the rows, and also you put this in the columns. So you're basically creating a matrix, basically. So here I have 6 parameters. Like, so 6 by 6 matrix you would create, and then of course then you are comparing each parameter against each other. So camera versus camera. So in this case we are not comparing camera versus camera. So that's why you have this one. You have this yellow highlighted cells. So And then screen as well, you can see screen versus screen, yellow, battery versus battery, yellow, and so on. These are all one because we are not comparing against each other. But now let's take the first row, camera versus screen, and you can see that 0.33, that is nothing but 1 by 3. Camera versus battery, in this case 0.20, it is nothing but 1 by 5. What are these values, fraction values and integer values? So these values, you get it from this scale. This is nothing but a scale. So in this scale, this is equal, camera and screen. In this case, camera and screen are the first parameters. So you are comparing camera with screen. And if you put 1, so you are in the middle of the scale. In the right side, it is 1 by 3, 1 by 5, 1 by 7, and 1 by 9. In the left side, 3, 5, 7, and 9. So if camera is more important, you will kind of go with these integers here in the left side. And if the screen is more important, you will go 1 by 3, 1 by 5, 1 by 7, and 1 by 9, and so on. So these are the values you are kind of feeling. Basically, whatever you have above this diagonal, top right side of the diagonal, this yellow diagonal here in this 6 by 6 matrix, you need to fill. And the bottom left diagonal is nothing but the reciprocal value of the top right. So in this case, for example, screen value is 1 by 3, battery is 1 by 5, and so on. And this is nothing but the reciprocal of this value. So 1 by 3 is 3, 1 by 5 is 5, 0.33 is 1 by 3. These are the reciprocal values basically. So you fill these here in the above this diagonal, and then once these values are filled, then you will fill this by looking at these values. But while filling this, the top right of this matrix, you can see that you are comparing two parameters, camera as well as screen. And in this case, screen is more important than the camera. That's why you put this value. And let's take this value, camera versus software. In this case, you think that camera and software both are important. That's why it is 1. And camera versus support, you feel that camera is more important than the support. So it is coming to this scale, which is like 5, and so on. So that's how you fill this. Once you fill this 6 by 6 matrix, then you can sum up these columns. Camera columns summed up, all these 6 rows are summed up, and then you get 15.20. Screen summed up, 7.87. These sum up, you can get like that. And the formula is here in this equation, sum of M2 to M7. So you can easily get these values. And once you got these weights, you have to distribute these weights again to all these parameters. So for that, you create the standardized value of the matrix. Standardized matrix. Okay, anyway, so these are the standardized matrix values here. This is nothing but you are kind of taking the value from here, in this case 1, divided by 15.20. So you are kind of distributing this 15.20 to all these parameters accordingly. So in this case, M2 by M8. M8 is 15.20. So here M3 by M8, M4 by M8, M5 by M8, M6 by M8, M7 by M8, and so on. So you distribute, so you get this. Now you have to find out the weighted average. For that, you can add all this value and divide it by 6. So you get the weighted average. That is, and then if you multiply that by 100, you will get the percentage. So here, with the percentage, you can rank. 29% is the highest rank. In this case, battery is more important, and here speed is the second